Hey folks, this is going to be our notes page 18 today. We're going to be talking about the path of light. That's the path that light has to travel in order for us to see it. Now, we're going to do a little bit of review as well, and this is going to take us all the way back to page 16 and 17 with the transverse waves and the electromagnetic spectrum. So, if you want to take a look at your page 17, it's got this really long electromagnetic spectrum on the front. We might not have talked about it in class yet, but we did talk about all the different types of waves. We talked about the radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma. And we may have said some things that they're used for. Radio is used for communication. Microwaves are used to cook food and other things. If you don't have those notes, make sure you get with a partner at some point and take care of them. One thing that we didn't talk very much about was how the electromagnetic spectrum, if you look at it, it starts off with very long wavelengths. Radio waves have very long wavelengths, and that means their frequency is pretty low compared to the other ones. So as you go down the spectrum, they get shorter and shorter and shorter and shorter and shorter and shorter and shorter. And then eventually, gamma waves have such short little wavelengths that you couldn't even fit the nucleus of an atom in between them. Radio waves have really long wavelengths, like the size of buildings or as long as you are tall. But then they start to get smaller a lot faster. And let's remind ourselves that short wavelengths equal a high energy, and a high energy means that they have a high frequency. Longer wavelengths, lower energy, lower frequency, all that good stuff. Now, this is stuff that we talked about last class. We'll talk about it a little bit more in class in the future. What I want to do right now is I want to create a little reminder. It's hard to memorize all 7 of them, especially if you want to learn them in order. So what I would like us to do is take a moment to imagine. So what you want to imagine right now is whatever you think the planet Venus would look like in a science fiction thing. Does it have like really tall buildings? The people in Venus, the Venusians, what are they like? Are you picturing it? Cool, cool. Okay. So you've got this civilization on Venus. It might be really advanced. It might be pretty ancient. I don't know what you're imagining. But what I want you to imagine is a spaceship comes down through the clouds of Venus, and the door to that spaceship opens, and outpour all of these glowing green monkeys. And these glowing green monkeys start just taking the planet over. And they take out these weird looking ray guns and they shoot the ray guns, and you can see the skeletons of the Venusians, and then they fall down dead. And then the radioactive monkeys conquer the entire planet. So if you pictured all of that, it's easier for some people to remember a picture that went with a story. Like, how these radioactive monkeys invaded the planet Venus using X-ray guns. Now, why are we bothering with this? Well, this is a really good way to remember all of your waves in order. So if you would, we'll just look at this right now. Radioactive. If you remember that radioactive monkeys invaded Venus using X-ray guns, you know the first letter of every electromagnetic wave. Radioactive stands for radio. Monkeys stands for microwave. Invaded stands for infrared. Venus stands for visible. Using stands for ultraviolet. X-ray stands for, well, X-ray, I couldn't think of anything else. And guns stand for gamma. I'm going to give you a minute to pause this video and copy this down on page 17. there's a little space for you to record how we're going to remember the electromagnetic spectrum. Go ahead and hit pause and do that now. I'll wait. Did you hit pause? Did you write it down? Well, I hope so. A lot of people were asking, do I have to write down this sentence? Could I have written down my own? And you know what? Yeah, sure. You could have made up your own sentence too. If you remember that random Martians infiltrated Venice using xanthan gum, sure, it still reminds you radio, microwave, infrared, visible, using is ultraviolet, X-ray, guns. If you remember that really mean individuals, blah, 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 make up your own sentence, however you remember them. But you should be able to tell me all 7 of them, and you should be able to tell me in order, starting with radio and ending with gamma. So what we're really going to look at today is the visible light part of the spectrum. And in our last class, we mentioned that visible light is one of those electromagnetic waves. It's part of the family, and it's the smallest part of the electromagnetic spectrum. It's really, really tiny part. And it's the only part we can actually see. And that's what's important, because we're going to talk about how we use visible light to see. Now, this is going to take us to our new page of notes. So if you would, go to the back of page 18. That is the new page. You have just received it. The back of the new page 18 is where we're going to start. If you need to pause at any point, please pause so that you can get yourself in the right spot to take notes. All right, so we're looking at this right here. We're looking at 3 new words: absorb, refract, and reflect. Now, if you hear the word absorb, what do you think of? I think of a sponge when I hear the word absorb. And when I hear the word absorb, it means that you're soaking up energy somehow. So right here where it says A, you see that light waves are coming down and hitting whatever this is, but they're getting like sucked up by them. That would be getting absorbed. B, we're showing refract. Refract means to bend a little bit. So you see that the light wave comes up here, it hits the glass prism, and instead of going straight like it was, it actually bends a little bit down. So refract means to bend. And the last one is reflect. And reflect is when you bounce off of something. So if I shone a light wave on something and it bounced off, that would be reflecting, like a mirror. A mirror will reflect light waves really well. So when I look at it, absorb, waves get soaked up by something, kind of like a sponge. A sponge absorbs water, just like some objects absorb light. Refract means the wave bends slightly. Like instead of going in a straight line, it kind of goes at an angle. And reflect means waves bounce off and change their direction. And that would be like a mirror. So let's take a second and look at ancient Egypt. An Egyptian fisherman is fishing in the Nile with his spear. He sees a fish below and stabs straight down, but misses the fish. What could have happened to the light to make him miss the fish? Before we talk about it, go ahead and hit pause and see if you can think about what happened. You might want to look at the words absorb, refract, or reflect. Now, in the next video, we'll talk about what could have happened. Hint, hint, look at the word refract. What does it mean?